Okay, next up is the second part of chemical bonding, talking about covalent bonding. Now, covalent bonding is usually the more, what do you call this? People say the convenient bonding lah, because it's very easy as compared to ionic bonding. Ionic bonding, you need to have transfer of electrons, stuff like that. You need to know how many electrons are being transferred. Then in terms of drawing, it's also much more troublesome lah, very mafan. Okay, covalent bonding is simpler. Okay, but usually covalent bonding, so people can get it wrong. Don't understand why. Okay, so we talk about covalent bonding. Okay, remember for ionic bonding, we're talking about metals and non-metals. So metals usually will lose the valence electrons, and then it will go to the non-metals. However, how about those that are in the middle? Remember again, metals usually we're talking about group 1, group 2, group 3. Non-metals usually talk about group 6 or group 7. Very seldom group 5. Very seldom. How about group 4 then? Group 4 will miss out, is it? So, for covalent bonding, we're talking about group 4 elements. Group 5, basically all the non-metals. Okay, so when non-metals, if they want to react with their own, with their own non-metals, they will share their valence electrons, because they obviously have already more than 3. Okay, so the bonding that when they share their valence electrons is called covalent bonding. Okay, now again, the goal here is still very simple. They want to attain the electronic configuration of a noble gas. Alright, and again, if it's one shell, they will have 2 electrons. If it's more than one shell, then they have 8. Now, when atoms combine by sharing electrons, you have a molecule. Again, just now I was talking about ionic compounds. You don't have molecules. This one, for covalent compounds, they have molecules. So a molecule is a group of 2 or more atoms held together by covalent bonding. So non-metallic elements exist as molecules because they can be made up of 2 or more identical atoms. So let's look at how electrons are shared between molecules of some elements, and primarily we'll go through hydrogen, chlorine and oxygen. Now for hydrogen, okay, you have, remember hydrogen has only one shell, so it has only one valence electron. So again, if it has one shell, then the goal is to get a duplet configuration, okay, to achieve the octet the configuration of a noble gas. So they will share these two each electron each, okay, and you'll form something like this. Again, when you draw your electrons, make sure that they are properly overlapped. Do not draw on the lines itself, because sometimes it can be a bit ambiguous. Markers can mark you down. Okay, so both now, when they share each electron each, they have stable duplet configuration. Very easy stuff. Okay, so the sharing of 2 electrons form a single covalent bond, and usually you represent a single covalent bond by 1 dash, like this. Okay, so I'm sure you learned your organic chemistry, right? So one covalent bonding is symbolized by 1 dash, like that. Please take note, for this one you don't need to know about it. Okay, this one sometimes in organic chem they do lah, but usually in organic chem only. Now let's look at chlorine. Okay, chlorine has 7 valence electron. So how about a chlorine molecule? Chlorine molecule, again, you have 7, right? Okay, always remember the rule is if it's in group 7, it will share 1 valence electron, okay, to form a octet configuration. Okay, so for group 7, okay, share 1 pair of electrons. Okay, so for group 6, and later on we talk about group 6 lah. Okay, be patient a bit. So group 7 will share 1 pair of valence electron. It will form again a single covalent bond. So you denote it by 1 dash, like that. How about oxygen? Now oxygen, okay, has 6 valence electrons each. So for oxygen gas, okay, because it has 6 valence electrons, it will share 2 pairs of electrons. Okay, so the rule is like this: if it's in group 6, okay, share 2 pairs. 2 pairs means my sharing Also wrong spelling. 2 pairs of electrons means altogether 4. Okay, so 2 from each atom. Okay, please take note, some of you all make careless mistakes because you already know, okay, share 2 pairs, then after that you draw 6 electrons outside. Okay, please take note, it must be 2 pairs. Okay, all together, one oxygen atom will now have 2, 4, 6, 8. This side will have 2, 4, 6, 8. Okay, so when you draw your electrons, especially when you talk about covalent structure, please recount again. Just make sure that each atom has 8 valence electrons. That's the goal. Okay, so again, when oxygen has already 2 pairs of electrons shared, that means it will form a double covalent bond. I'm sure you all have seen double bond, right? Okay. Okay, so you represent it in like an equal sign, 2 dashes instead of 1. Okay, so we already finished our first slide for covalent bonding. That was fast. Managed to cover it within 6 minutes. Feel very sleepy on a Saturday afternoon. Saturday evening. Getting older already. Yeah, but I'm sure you all are still awake. Okay, hopefully still watching my videos lah. Now, when you have molecules of compound, just now we talked about molecules of element, both atoms sharing electrons, both identical atoms lah. But this time around, we'll talk about molecules of compounds where 2 or more different types of atoms form covalent bonding. Okay, so in this set of slides, we'll look at water, methane, and carbon dioxide. For water, okay, very easy. Your water molecule is formed by the reaction of 2 hydrogen atoms with 1 oxygen atom. You've been taught right from primary school is H2O. Okay, so all 3 atoms will need to attain the noble gas configuration. So if you look at this slide, okay, your oxygen is the one in the middle. Okay, the central atom. Okay, always, how do you know which one is the central atom? The one with the least number of atoms in that compound is always the central atom. So this one is central atom, then you have 1 pair and 1 pair, because hydrogen only needs 1 more electron. The other hydrogen also needs 1 more electron. The oxygen would want to share 2 pairs. Okay, so 1 pair each with each hydrogen atom. So altogether there's 2 single covalent bonding. Okay. Okay. Now let's talk about methane. Methane is again simpler. Okay, you have CH4, and then your central atom again being, you have carbon and hydrogen, 4 hydrogen atoms. So the one with the least number, okay, carbon obviously will be the central atom. So the carbon will have 4 valence electron. When carbon has 4 valence electron, remember the pattern again. Group 7 needs 1 pair. Group 6 need 2 pair. Group 5 need 3 pair. Group 4 need 4 pair. So carbon is in group 4. It will need 4 pairs of electrons. So it will be surrounded by 4 atoms of hydrogen, who all need 1 pair only. Okay, so it will form a formula of CH4. So methane and altogether has 4 single covalent bonds. Okay, then we talk about carbon dioxide. Now carbon dioxide is slightly complex. Okay, again the rule is simple. You have C and O2. So obviously C being the lesser number here will be the central atom. Carbon again has 4 valence electron. Okay, so it will need to share 4 pairs. Now where do they get these 4 pairs of electron? It has 4 on its own. So oxygen, one side of oxygen needs 2 pairs. The other side of oxygen needs another 2 pairs. Okay, so obviously you can get these 2 pairs from there. Okay, so once you have that, then okay, voila, you're okay. Please take note, do not draw it like that. Okay, in your exam, I want to see the shell. Okay, you don't see the shell, obviously it's wrong. Okay, so when you draw it in terms of structural formula, then obviously the carbon is surrounded by 2 dashes of O on each side. Okay, it denotes by double covalent bonding. Okay, that's it. Very simple, right? Okay, for covalent bonding. Okay, so usually they would like to ask for carbon dioxide. Okay, very simple. Okay, this is the third set of slides. Okay, we talk about the properties. This part is very important, people. I always the exam, when it comes to bonding, they always like to talk about volatility and electrical conductivity. Okay, so volatility, again, if you can recall from the ionic compound slides, is referring to melting and boiling point. Okay, many simple covalent substances are usually liquids or gases at room temperature. Why? Because in terms of melting point and boiling point, they have low melting point, low BP. Okay, so when you talk about volatility, remember when you talk about ionic compounds, they have high melting point, high boiling point. In terms of volatility, they are non-volatile or low volatility. But for a covalent compound, is the opposite. Because they have low melting point, low boiling point, they are very volatile. So they are highly volatile liquids. Okay. Now when you talk about volatility again, let's say perfume. Perfume, you leave it out in the open, it will evaporate very fast. That means the boiling point is very low. So when the boiling point is very low, we call it a very highly volatile liquid. Okay. Now to understand the explanation between covalent bonding, okay, let's talk about the hydrogen molecule, H and H. Okay. Now when you talk about melting point and boiling point, you are not talking about the sharing of electrons. Okay, let's say this part, you do not want to break this one. This one is very strong. Okay, you're not breaking it. Okay, the problem here is when you talk about covalent bonding, it's actually very strong between the atom Okay, strong between atoms. But when you're trying to break, is this part. What is that part? Is the intermolecular bonding. Okay, and the fancy name I use for it is called van der Waals, because this guy is the one that discovered intermolecular bonding. So this intermolecular bonding is weak. This is the one that you are trying to break, okay, when you are trying to boil it or melt it. So this one is very weak. So that's why you just need very little heat energy to overcome this intermolecular bonding. Okay. Now, in exam, do you need to talk about between the atoms is very strong bonding, strong covalent bonding? You don't need to. Okay. But if you're an A1 student and you really want to express yourself, provided you really know the answer, go on. By all ahead, by whatever head, go ahead. Okay. By whatever head, go ahead. What the hell am I talking about? Okay. So the first point you don't need to say. Okay, you don't need to say, oh, between the atoms is very strong covalent bonding. It's fine. They all know that. What we're interested is for it to boil and for it to melt, we are trying to break the intermolecular bonding. And the intermolecular bonding, or weak van der Waals force of attraction, is very weak. Okay, that's why it's very, very little heat energy required to break the molecules. Okay, I hope you know how to explain this. Just memorize if you can't understand. Okay, because it's very, very important. Usually they like to come up. Okay, for solubility is the direct opposite of ionic compounds. Covalent molecules are insoluble in water and soluble in organic solvents. If you can recall, ionic compounds are soluble in water and insoluble in organic solvent. Of course, there are a few exceptions. Chlorine, hydrogen chloride, alcohol, and sugar are covalent substances, but they are soluble in water. So these are the ones that deviate from the norm lah. Okay, last one. Electrical conductivity, you don't need to worry so much. Most covalent elements do not conduct electricity because in solid, liquid, or gaseous state. Okay, because they don't have two things that you need to conduct electricity. One is free moving ions and free moving electrons. Okay, so we call it mobile ions or delocalized electrons. Must state both. Must state both to show the marker that, look, I know what you're talking about. You don't have these two things, so cannot conduct electricity. Okay. Of course, there are exceptions also. Carbon in the form of graphite conducts electricity. Then hydrogen chloride, sulfur dioxide, ammonia, these things, even though they are covalent compounds, when they react with water, they conduct electricity. So these are the exceptions that you need to take care of. Okay. Do you need to talk about the exceptions when you're explaining this thing? Don't need. Again, if you want to show that you're an A1 student, go ahead. Okay, but you need to get your main explanation correct first. Alright, so we're done for this one. Then we are talking about the last one. The last one is very simple. Yes, I think it's only 3 slides. So in the background is my Facebook. Hopefully all of you see this. Okay. Now, when you want to write covalent compound formulas, okay, there is no hard and fast rule for this. Okay, now the name of a covalent compound tells us, a bit slow here, the element it contains, the number of each type of atom or molecule contains, okay, shown by the prefixes. Okay, so these things you need to know lah. The prefix mono means 1, di means 2, tri means 3, tetra means 4, penta means 5. The prefix is slightly different from the ones that you learn in physics for those physics students, so please take note. Okay, what is the chemical formula of carbon dioxide? Now, from the formula for carbon dioxide, you do know that di means 2. So obviously, when you talk about carbon dioxide, means there is CO2. Okay, that's how you know it. But I guess a lot of you have already known the formula of carbon dioxide right from the start. Okay, so the di means is 2 oxygen atoms. Okay, now some of you are probably asking, Mr. Gan, then why you never said monocarbon dioxide? Don't need. If it's 1, usually you don't need to say it unless you know that there's 2 sets of compounds that is possible. One is carbon monoxide, the other one is carbon dioxide. Then you state. If let's say you know that confirm usually is there's only one most of the time, don't need to write. Okay, so like nitrogen monoxide, you know, there's always nitrogen dioxide, nitrogen monoxide, you got dinitrogen monoxide, so many possibilities. Then you can explicitly say lah. Okay, so like dinitrogen means 2 nitrogen atoms, okay, N2, and then obviously this one it's asking me to pay. Wait. Okay, dinitrogen means N2, so monoxide means O1. Okay, you don't need to write the O1, just write O, so N2O. That's it. Okay, so the 1 is not indicated in the formula. Let's say dinitrogen tetroxide. Okay, again, dinitrogen means 2 nitrogen atoms, tetroxide means 4 oxygen atoms. So it's N2O4. That's it. Right, okay. Common covalent substances like ammonia, okay, hydrogen peroxide, methane, ozone, and water, you need to know the common name lah. So for this one, you obviously, for ammonia, you don't call it nitrogen trihydride or something like that. Okay, you don't need, because these are commonly used. Okay, so they already have a name behind it. Okay, right, that's about it. Okay, so for chemical bonding, few things you need to take note. Again, dot and cross diagram, you need to know how to draw it. Okay, the explanation behind it. Okay, the bonding. Okay, again, ionic bonding, it refers to electrostatic force of attraction. Covalent bonding, it refers to either van der Waals force of attraction or intermolecular bonding. Okay, then you need to talk about properties. There's only volatility and electrical conductivity. Once you master that, again, take a look at your tendencies. Try and sit down and do. Okay, sit down and do. You check the answers. Okay, you check whether you get correct. If you get it wrong, you don't understand the explanation, look for me. Okay, I'll try and help you. Try to post it up on Facebook so everybody will see. Everybody can volunteer to help you. Then all of us will learn to benefit. Okay, I hope all of you really appreciate the effort that I'm going through with you right now. Again, I said if I can see the effort on your side, I don't mind doing it over and over again. Of course, I can't do it for all the chapters. I'll try to do it for most of the chapters that I think is important. Okay, so happy studying, the most important thing is do your part. Okay, sit down, do your 10 year series. If you've done it once, you got it time, do it over and over again. Master the questions. Try to think what they want to assess you. Okay, once you know that what the enemy, in this case, what O levels want to test you, then you're halfway there. If you're comfortable, you can do it, then you're on the way to A1. Okay, thank you, people. Have a good night. Don't study too late. Okay, please make sure you have maximum sufficient rest. I'll see you guys tomorrow. I'll try to upload video on kinetic particle theory. Okay, then we'll see how it goes. Please like the video, then I can see that you all are actually viewing the video. Thank you so much. Bye bye.